Welcome to Unacademy Grow channel. So we were doing a series on 50 MCQ problems on arrays and linked lists as a part of cracking the coding interview uh, playlist that we are creating. So we already solved 40 out of these 50 questions, and this is the last session in that series, in which we will be doing the remaining 10 problems, the last 10 problems. I will quickly give you the problems and the solutions. We will not waste time today. Okay, so I'll not wait for the complete solution, and I'll just be solving the question so that anyone who is watching the recorded session can get benefited from it. Cool. Let's begin the session now. So I'll just this is the title of the video: 50 MCQ questions on arrays and linked lists. And I am having this playlist going on, cracking the coding interview. I'll be making more such sessions, not just MCQ problems, aptitude problems, and lot and lot of puzzles, and so on and so forth. Okay, so we will be doing all of those under the same umbrella. So stay tuned on this channel, and we will be solving basically everything. So this is the question number 41 that we have. So it says the following C function takes a simple linked list as an input argument. Okay, which means every node is connected to the next node. That's a simple linked list. And it modifies, and by default, when it says it takes a linked list as an input argument, what does it mean? It takes the head pointer. So this is the head pointer. And this head pointer is taken as an argument by this function. So it modifies the list by moving the last element to the front of the list and returns the modifiers list. So it has to basically move the last element. Let's say this is the last element. So to the front, and will return the modified list. So some part of the code is blank, and we need to figure out what should come in the missing part. Right. So let's see what the code is. So move to front is the function, and we have head, which is okay. So now they are taking two pointers P and Q. So if head is null, or head connects is null, return head. So basically, like if you have only one node in the linked list, or there are no nodes in the linked list, you will just directly return it, because there is no point in moving the last element to the front. So the linked list remains same if there is only one node or zero nodes. So this part is correct. Now they are saying Q is null and P is head. Okay, that's okay. So while P is next is not null, we are saying Q is P and P is next. So basically we are keeping track of so like this is like moving to the next element every time. P is moving to the next element while its next is not null. So P will move till the last element, and Q will be moving to the second last element. So at the end of this loop, what will happen? P will be pointing to the last element of the linked list, and Q will be pointing to the second last element of the linked list. Okay. So what is the task in hand? Now we have to fill this line. We just have to basically move the last element to the head. So basically what we want is, we want P ka next. P is last element, right? So we want P ka next element to be head. One thing, which will make sure ki last element is now the first element. Also so basically we are making this connection. We are making this connection, because we want this element to be the first element. Also now we want to break this connection. If we break this connection, then we are good, right? We want to break this connection also. So what we want is, we want Q's next to be null. Okay. Also, one thing we want this to be head now. So we want head to be P. So these are the three changes that we want. So these three changes are mentioned in which option? So this is not correct. Q is not null. This is not correct. Q ka next is null, but head is. So we want this step to be done at the end, right? We cannot move head first. We cannot move head first. We cannot move head first. Otherwise, this, like, yeah, this statement won't make sense. So we want this Q ka next to be null, and then P ka next to be head, and then we will make head equal to P, which is correct. So this is our right option. Option D. So let's move to the next problem. Okay. So the question says, let P be a single linked list. So P is a single linked list. So P is basically the head pointer of a single linked list. Let Q be a pointer to an intermediate node X in the list. Let's say Q is a pointer to an intermediate node, some node in the list. What is the worst case time complexity of the best known algorithm to delete the node Q from the list? It's again not that difficult. So since we are given a pointer to some random node, we are given just given a pointer to some random node. We just cannot delete it like easily. We need the pointer to the node before it as well. Since we want to delete, let's say, this node, we want to basically make this connection. So we want to basically make this connection and then free this node. That's how deletion works. So we will be wanting a pointer to the previous node of this node Q, and we don't have a pointer to the previous node of the node Q. So to get that pointer, we need to traverse the entire linked list till the previous node of node Q, which might take in worst case order n time, right? So order n should be correct. In order n, we can definitely go to the node which is just before this node Q, and then just what we need to do is we need to make this connection, which can be done in constant time, and then we can free this node, which can be done in constant time. So in worst case, we might be requiring order of n operations. Right. Cool. Let's move to the next problem. So in a doubly linked list, the number of pointers affected by insertion operation will be. In a doubly linked list, the number of pointers affected for an insertion operation will be. Hi Krishna. So we are given a doubly linked list. It looks like this. So every node is connected to its next node and its previous node as well. So what is the number of pointers affected if we want to insert a node? And see, they have not given key at which position we want to insert it. So let's assume any position, okay? And we want to just tell ki how many pointers will be affected while inserting a new node. Okay. So there are few cases like if we insert at the head, if we insert at the head or like at the front. So if we insert at the head, then only these two pointers will be affected. Then only these two pointers will be affected. So if we insert at the head, two pointers will be affected. And if we insert at the tail or the last element, again only two pointers will be affected. See, two is not an option, so definitely like this problem, like the options are incorrect. So if we insert at the head, two pointers will be affected. If we insert at the tail, again two pointers will be affected. If we insert in the middle, so if we insert somewhere here, then this pointer should point here, this pointer should point here, this pointer should point here, and this pointer should point here. Basically, these four pointers will be affected. So if we insert somewhere in the middle, four pointers will be affected, right? So actually, none of the options is correct. First, it depends on where you are inserting it, and second, like this is the answer. If you inserted the head or tail, then two pointers get affected, and if you insert anywhere in the middle, four pointers get affected. So like none of the options is correct. Okay, let's move to the next problem. So this question has been asked in GATE before. So two matrices M1 and M2 are to be stored in arrays A and B respectively. Each array can be stored either in row major or column major order in contiguous memory locations. The time complexity of an algorithm to compute M1 into M2 will be. So here we are given two matrices M1 and M2. And we want to compute M1 into M2. So M1 into M2, how is it calculated? So the first element will be, we multiply all these elements to all these elements and add them, and that value will be present here. Similarly, like we go like that. So first row and first column. So if we see here, this element will be first row and second column, and so on. So basically, if we have to populate mth row and nth column here, we take mth row of M1 and nth column of M2. We multiply them pairwise, and then we add them. That's all we do. So the thing is, row major order is like storing them like this, or column major order is like storing M2 like this and this. So ideally, since we have to take rows of M1, and columns of M2, see, any memory location you can take out in constant time anyways in the memory, because you know the address. You can compute the address of any location in constant time, and you can take that element out in constant time. It's just that if the element is present in hard disk, okay, if the element is present in hard disk, it's better to extract all the elements in a column once. It will, like, so the hit rate will increase. of the cache. So it's like more like computer architecture problem. So the hit rate will increase if we store A in row major order and B in column major order, because hit rate only, right? Like, so because you are storing the entire row, and since you are multiplying this entire row by this entire column, you most likely will have this entire row and entire column in the cache. So hit rate will increase if you have this. So your time might slightly increase, but they're not talking about that time. They're talking about the time complexity of the algorithm. See, the time complexity of the algorithm doesn't change. Multiplying two matrices, you have to multiply all these elements with all these elements, and so on. We know that it's a standard order n cube problem. It won't change by the order, like by the order in which you are storing the elements. So row measure ho या column measure ho, like the time complexity of the algorithm remains same, like multiplying two matrices. So it's a trick question. It doesn't matter, but yeah, hit rate might increase a bit. Overall, like if you store it in this fashion, like A in row measure and B in column measure order, then you might okay have some like better time, like it might take lesser time because of the hit rates, but overall time complexity of the algorithm won't change. Okay, let's move to the next problem. Suppose you're given an array S 1 to n and a procedure reverse Sij, which reverses the order of elements in S between positions I and j, both inclusive. What does the following sequence do? So given an array S 1 to n. So there are like n elements. Let's say the elements are also 1 to n only. Doesn't matter. Okay. And a procedure reverse Sij, which will reverse the order of elements in S between the positions I and j, both inclusive. And what does the following sequence do? We are first reversing the elements from 1 to k. So here let's say n is equal to 6 and k is equal to 2. So the elements are 1, 2, 3, 4, 5, 6, and k is equal to 2. So first we are reversing elements from 1 and 2. So basically it will become 2, 1, 3, 4, 5, 6. Then it says ki you have to reverse S, K1, K plus 1 and K. This is ambiguous. So how can you reverse between K plus 1 and K? It says that it will reverse between positions I and J, both inclusive. So this statement is like ambiguous. We have to see. So like it might be reversing all the elements from K to K plus 1, or it might not do anything. So we will try both. We will try both, okay? In such ambiguous situations. Let's first say ki this statement is ambiguous and like this statement won't do anything. Okay. Then like what happens? We will ignore this statement and move forward. Then we will reverse all the elements from 1 to n. So this will become 6, 5, 4, 3, 1, 2. So what happened to the original string? What happened to the original array? If you think about it. The first option is rotate S left by k positions. So this doesn't happen. This doesn't happen because if you rotate S left by k positions, it would have become 3, 4, 5, 6, 1, 2. But we have this. Leaves S unchanged is wrong. Reverse all elements is wrong. So yeah, like for so that like assumption, like again that's an ambiguous problem. So we have to solve it both ways. So we actually were not able to do anything. All of these three things. If we didn't do anything, using this statement. Now let's do something with this statement. Okay, now what we will do is, so this is the array that we have after the first statement. We reversed all the elements from 1 to k. Sorry. Now let's say we reverse all the elements from k plus 1 to k. So what is k plus 1? K plus 1 is 3 and k is 2. So we have to reverse all the elements from third element to second element. So how will it work? Um, it doesn't make sense actually. Like this is really ambiguous problem. And this is also asked in gate. So gate sometimes asks these type of questions in which you cannot do anything. Sometimes they give bonuses for these questions, okay, if they are really ambiguous. So from k plus 1 till k. So what does it mean? कि यहाँ से लेके यहाँ तक सब रिवर्स करना है. Okay. So basically it will, I guess, since we will reverse everything after k plus 1, because like in the iterator we will never be reaching k actually. So what we will get is 2 1 6 5 4 3. So if you basically implement this in C language, it's again ambiguous, but if you implement this in C language, what will happen? It will try to reverse everything from k plus 1, k plus 2, k plus 3 up to k, but we will never reach k. So we'll only be able to reverse till here. Okay, and then when we reverse the entire string, we will get 3 4 5 6 1 2. Right. So it is rotating s left by k positions if we do it this way. But like again, like this problem has ambiguity, and I would not suggest like you can leave this question, like these type of questions in exam. Okay. Option A is correct if we do it this way, and if we ignore this statement, then option D is correct. So it's like ambiguous. So the answer which officially it's is written on the website is A, but yeah, it's ambiguous. Okay, let's move to the next problem. An n cross n array V is defined as follows. So you have an array matrix V basically, and it's n cross n. So let's say it's 3 cross 3. Let's say it's 3 cross 3. And we are saying ki Vij is I minus j. What is the sum of all the elements? It's an easy problem. So Vij, so basically V1 comma 1 will be 0. All these elements will be 0 because they are I comma j. Basically I comma I. So V of I comma I will be I minus I, which is 0. Then like this element will be 1 minus 2. So will minus 1. This element will be minus 2. This element will be plus 1. This element will be minus 1. This element will be 1, and this element will be 2, and this element will be 1. So basically sum of all these elements will become 0, and always you can check, sum of all the elements will always become 0. Doesn't matter. And you can prove it mathematically as well, because for like that's how matrices work. For every I comma j you will have a j comma I as well in the matrix. Since it's an n cross n matrix, for every I comma j there will be a j comma I. So the sum of these two elements will always be 0, because it is I minus j plus j minus I. So this, which is 0. So for all corresponding elements it will be 0, all the counter elements. And anyways for the diagonal elements they will be I comma I, they will anyways be 0. So actually sum of all the elements will always be 0. Okay. Let's move to the next problem. Okay, this is a very tricky question, very difficult question to solve in exams. So x is an array of the form 1 to n different numbers. If xi is greater than xj and I is less than j, then the pair ij is called an inversion. The permutation of n elements, the number of inversions are. So number of inversions means expected number of inversions here, okay? So let's say we just take any permutation of 1 to 4, 3 to 4, 1. So firstly, how many pair ij we have? 4c2, or like since we have 4 elements, 4c2 equal to 6. There are 6 pairs. What are the 6 pairs? Let me write the index here as well. Let's say the index of these elements are 1, 2, 3 and 4. So what are the 6 different pairs possible? 1 comma 2, 1 comma 3, 1 comma 4, 2 comma 3, 2 comma 4 and 3 comma 4. These are the 6 pairs. So is 1 comma 2 an inversion? So any I comma j will be an inversion if I is less than j but xi is greater than xj. So basically, like since like a greater element is present before a smaller element. So and at 1 and 2, is it an inversion? Yes, because 3 is greater than 2. So it is an inversion. At 1 comma 3, is it an inversion? No, because 3 is less than 4. At 1 comma 4, is it an inversion? Yes, because 3 is greater than 1. At 2 comma 3, is it an inversion? So 2 and 4. So it's not an inversion. At 2 comma 4, is it an inversion? Yes, because 2 is greater than 1. At 3 comma 4, is it an inversion? Yes, because 4 is greater than 1. So in this array, out of 6, there were 4 inversions. In this array, out of 6, there were 4 inversions. Right. So what is the expected number of inversions? We always know in such cases, the probability of having an inversion is 0.2 or 0.5. So a particular pair can be an inversion or it might not be an inversion. So basically the probability of any pair being an inversion will always be half. It might be or it might not be an inversion. So what is the expected number of inversions? So the probability of a pair being an inversion times the number of pairs. We know. Okay, this is the expected number of inversions that we can have. The total number of pairs we will have is NC2, and the probability of any one of these pairs being an inversion is half. So the answer is NC2 into half, which is n minus 1. NC2 is n minus 1 by 2. So n minus 1 by 2 into 2, which is n minus 1 by 4. This is the expected number of inversions that we will get. Yeah. Got it. So let's move to the next problem. So just 3 more problems remaining. A two-dimensional array ARR 2010 with 4 words per memory cell. Let the base address of the array be 100. Elements are stored in row major order and the first element is array of 00. Find the address of array 100 11 5. Sorry, 11 5. These problems are really easy. So just start with the base element and we have to find the address of 11 5. So basically 11 rows have completely passed off. 11 rows have completely passed off. since it is 0 indexed, 11 rows have completely passed off. This is 12th. Array of 11 means 12th basically row. So 11 rows are completely gone, and in each row, each row there were 10 elements. In each row there were 10 elements. 11 rows each having 10 elements. These many elements are completely gone. Plus, how many elements more are gone? 5 more elements are gone. 5 more elements are gone. So this is the total number of elements which are already passed. And consumed each element consumed 4 words of memory. Each element consumed 4 words of memory. So this is the address of the this particular element, array of 11 5. So which is base is 100. This is 110 plus 515. 115 into 4. What is 115 into 4? 5 4s are 20. 6 460 plus 100, which is 560. Okay, easy problem. Always go with this logic, even if it is a 3D array, 4D array, any D array. Okay, this will always work. After the base element, just see how many rows have passed, how many like slices have passed, and keep multiplying. Okay. Okay, let's move to the next problem. Again, like this is a similar problem, but here we have to come up with a general formula. So a three-dimensional array in C language is declared as an integer array x, y, z. Now consider the array elements are stored such that it is in row measure order and indexing start from 0. So the formula for computing the address of an item of location array of P, Q, R, take W to the word length. And same problem. So think about it. What happens here? So here also we will have base plus. So let's call these as slices, these as rows, these as columns. So P slices have completely passed. P slices have completely passed. So in every slice, there were Y rows and Z columns. We don't have to take care of Q and R now. So in every slice, there were Y rows and Z columns. So P into Y into Z. Plus, now Q rows have also passed. So Q rows have passed, and in each row there were Z elements or Z columns. Okay. Plus R more elements have passed. R more elements have passed, and each of these elements took up W space. So that's our answer. Right? Easy. You just have to count the number of elements which are already passed. So which option is it? Y, Z, P, Z, Q, and R. B, option B. Okay. Let's move to the next last problem. Okay, it's not loading. We have an image question. Basically, a code snippet is given. So we just need to find out what this code snippet will print. So int main, we have a 2D array of size 20 elements, 4 cross 5, and these are the elements. Very simple: 1 2 3 4 5 6 7. So you need to print this element. Okay, so always solve these problems inside out. We have seen, like, when we have complex pointer problems, always solve them inside out. So, like, what is the most inside one? This is like the innermost bracket. So A plus, A is what? A is a pointer to the entire like 2D array. And we know that if we do A plus 1, A plus 2, we will be increasing rows. Like A is the first row, A plus 1 will be the second row, A plus 2 will be the third row, and so on. So what are we adding to the A? Star star A. Star A is what? So first dereferencing will get you to the first row. First dereferencing will get you to the first row. Second dereferencing will get you to the first column also. So basically 1. Star A is 1, right? First row, and then inside that first column. So star is like A00. Only star A is A0. A0 is just the first row, entire row. A00 is like the first row and the first column, which means 1. So star A is 1. So basically we are adding 3 to A. So this is A plus 1, this is A plus 2, this is A plus 3. This is A plus 3. Which means this entire thing becomes third row. And we dereference it. We dereference it once, which means we are in the third row. We are in the third row. Now in the third row, we are adding 3. So in the third row, if we add 1, we will get here. Right. In the third row, if we add 1, we will get here. In the third row, if we add 2, we will get here. In the third row, if we add 3, we will get here. So we are incrementing in columns. So this is like adding 3 in the third row. And then we again dereference it. So this element is what we will be printing. 19. Okay, this is very common. Like if you know little bit of pointers, that's very easy. So first dereference it, so we get to the third row, and in the third row we are adding 3, so we are moving the pointer to 3 positions to the right, and then we again dereference it, so we are actually referencing this element, which is 19. Okay, so this was our last problem. We actually solved 50 problems on arrays and linked lists. These are very important problems. If you are able to solve all of them, try to see my 2 more videos in this series, so in which we have solved all the 50 problems, like different sort of problems on arrays, linked list, like different types of linked list arrays, all MCQ problems which can be asked in coding interviews. Like before like the interview round, there is generally uh, screening round or MCQ round which is scheduled, and these type of questions can be asked in screening rounds or MCQ rounds. So you have to be ready with that. And this is the first series of arrays in English. We will have more such MCQ problem series like stack, queues, and so on. And yeah, thank you. Do subscribe to the channel. And today in evening we will have an interesting session. Like it's like on like it will get scheduled, okay, really soon. So yeah, like today evening at 8 p.m. we will have another session. Let's meet in evening. Thanks for joining the session. Have a great day. Bye bye.